Ladies and gentlemen, welcome back to another episode of Cosmic Catastrophe exclusively on Rumble. Saturday night, 8 p.m. Mountain Time. I'm your host, Diamond, from the Oppenheimer Ranch Project. And joining us today, as usual, is my lovely partner and co-host, Leah Shaper.
Hello.
I think it's time that we had the talk.
Oh, yeah?
Yes.
What talk is that?
We are no longer doing a radio show. We're exclusively on Rumble with this science show that we do every week. And I don't think that the title is appropriate for what we're doing. It used to be, and we often talk about cosmic catastrophe and events like that, but we are more broad-based. So those of you listening tonight can help us out. What do you think the show should be called? Is it like Magnetic Reversal News, Saturday Night Update? What is it? What are we doing here?
I don't think it should be Magnetic Reversal News simply because we talk about topics much more wide-ranging than that.
So something like Unindoctrinated Science, Saturday.
Right, something like that.
All right, so leave your comments below on some suggestions on the name of the show exclusively on Rumble. And we will consider them all.
Cool.
So we're going to be, and also there's a new requirement for us as Rumble premium content creators. We need to have the more unique chatters we have, the better. We already reached the goal for this month, but it may increase. So if you've never left a comment below, just leave a chat. That's all you got to do to help us out. And we've got a great show ahead. We're going to be talking about a new paper coming out that's all over. And, I thought it was BS from the moment I read it and just skimmed through some of the information. And now that I've looked deeper into it, I think that there's a lot of problems with the headlines that they're using and some of the claims that they're making.
Right. I would, the data, the new data is interesting, but in my view, you cannot come to big claims with this data because it is a very limited data set, and the ability to compare it to previous data that we had is also very limited, as is the previous data that we had, but we'll get into that. So yeah, I think the conclusions and the hype about it is the problem, in my opinion.
All right. So here we go. Here is the first in a number of articles we're going to be talking about today. This comes from the International Environment Forum. Southern Ocean circulation reversed. It says, and this is coming out July 1st, a major reversal in ocean circulation has been detected in the Southern Ocean for the first time, with key climate implications. First of all, let me just tell you, all of these articles that are written about the paper, the longer I read through it, the more I realized that all it was is a fear porn article that was crafted to scare you.
Yes.
And it just increases paragraph after paragraph.
Yes.
It's not meant to inform in any way on what they're actually talking about down there, in my opinion.
Yeah.
And that's infuriating.
Well, and some of the fear porn is based on claims that I don't see are real or confirmed at all.
Yeah. So, and here's what we're talking about. Here's another article about the same topic, and it says Southern Ocean current reverses for the first time, signaling risk of climate system collapse. Oh my goodness, the system is going to collapse because we just determined that some seawater in Antarctica has increased in salinity a tiny amount.
Well, the title in and of itself is really problematic. Reverses for the first time, we do not know that at all. We haven't been collecting data long enough to know that.
That's true. But additionally, the only data that they're showing here is a change in salinity and not like flow rates or anything like that.
Yes.
And the data is coming from a satellite in space.
Well, gosh, I have so many problems with this. I don't even know where to begin. But let's start with that, the satellite data. So there's a new technology that is allowing the observation of the salinity and temperature in the Antarctic. And they're using that to compare it with previous data, which comes from Argo floats, which are these buoys that measure salinity and temperature over something like 1,000 meters of depth. So, they'll be at the surface for like 10 days, and then on schedule, they'll sink and measure the observations 1,000 meters below, slowly come up, take more observations, and then continue on and do the same thing, drop again. So in the PNOS paper that informs all of these articles, they never discuss how they calibrate the Argo float data with the satellite data. There's no discussion about that at all. This is a very, very brief paper. Not to mention the fact that the Argo floats have only been in place since 1999. So we don't have a long record of data. And yet I keep seeing these references in these media articles that say, like, this is an example. This is from the IEF World article, the first article that you brought up.
Yeah.
They say, they have a sentence in here that says, since the early 1980s, surface water had been getting fresher, meaning less saline, and colder, helping sea ice expand. We don't have that data. We only have data from 1999, as far as I know. And then we're comparing it to brand new satellite data with a brand new technology. And there is no discussion about how those two data sets have been calibrated with each other.
Agreed. And in the paper itself, all of the figures that they show only go back to 2011.
Yes.
On all the figures.
Yes.
And when you look at a data set like this, which is overlapping stratification anomaly in blue, sea ice extent in black, and SSS anomaly. So is that sea surface salinity?
Well, it's funny because they never tell you what that acronym is in this paper.
I think that's what it is,
figure.
Because there's a spike in sea surface salinity here in 2023.
That's what I assumed as well. Yeah.
But overall, when you're looking at the data set, there is no trend to suggest anything in the entirety of the data.
Now, I can see potentially, and I will say potentially is very important here, I can see the potential for a pattern, right? I see, like, if you look at...
there is a correlation in the data.
Well, two things. There's potentially both a pattern and potentially both a correlation.
Yeah.
But if you look at all of these lines, like the black line, right? It goes up, it goes down, it comes up again, it goes down again. Right. And you have a similar thing kind of going on with the red line. Now, granted, the second set of the black line where it kind of like goes up and down, the whole thing is lower than the first set. But this amount of data is so minimal, you cannot conclude any pattern from this, nor can you conclude correlation. It's like taking two data points and one is lower than the other and saying, oh, it's a downward trend. That's essentially what they've done here.
Yeah, it certainly doesn't allude to anything about ocean currents.
No.
But what you can see from this minuscule amount of data, which makes sense, is when the sea ice is very high in Antarctica, the salinity is very low. And that has to do with calving. So you get more freshwater calving when there's more sea ice, which is going to dilute the ocean. And the opposite effect occurs when sea ice is low, salinity is high.
Right.
And so it's not showing a current is shutting down for the first time ever. It's showing a relationship between the amount of sea ice and the salinity nearby.
Well, and that's something else that's really funny about all of this. If you read through the paper and all of the articles, there's this discussion about how, well, all of the climate models actually told us that global warming, I don't even remember how they put it because it doesn't even make sense, but they basically say that the models told them that increased salinity at the surface would actually increase sea ice. And they're startled because, oh my God, it's actually the reverse. And it's like, I don't even then your climate models don't even make sense. And then they do other things, like they say, okay, like so in figure B right here, where we have these maps of the Antarctic Sea, they point out these polynyas. They're open water areas surrounded by ice that opened up. And they're like, oh my God, look, these opened up in 2016 and 2017. They haven't opened up since the 1970s. And I'm going like, okay, they opened up in the 1970s, they closed again, and they opened again. What are you freaking out about? Like that, it clearly doesn't follow the trend that you're trying to fearmonger about.
Yeah. Additionally, I mean, let's just talk about reality. All right. The reality is that Antarctica has thousands and thousands of square miles of sea ice.
Mm-hmm.
It is unimaginable. It would cover all of North America, 500 feet thick.
Right.
It's a gigantic amount of sea ice, and it varies. And just recently, it was the highest ever recorded since we began recording the data.
Yeah.
Back in I don't know if it was 2016 or 2014. Somewhere back then was the most.
2014.
Okay. And here you can see, this is yesterday's sea ice extent. The orange line represents the average of all data that we've ever had. And you can see that in some places it's further out.
Mm-hmm.
In some places it's further in. There's really no appreciable difference in the entirety of the data here.
Well, it's funny too, because there's this line that's used in one of these articles where they say, oh my God, Antarctica has lost an area of sea ice that's equivalent to the area of Greenland, which is minuscule compared to Antarctica.
I wish I had a Greenland overlay we could put on.
I know. That's what I was hoping for too.
And additionally, the ice sheet works in different ways. So see these areas where it's extended past the average line?
Yeah.
Like down in the Southwest. When the sheet gets really long like that, natural processes occur called ice calving. So if there's less ice, we just saw it in that graph, there's going to be less calving. If there's more ice in some areas, there's going to be more calving. Nothing to do with the ocean currents.
Right.
And there's another problem that I'd like to bring up before we get to the other problem.
There's more than that.
Ice has been in Antarctica for tens of millions of years.
Mm-hmm.
You know, it's estimated to go maybe 40 million years. Antarctica has been exactly like it is. And there's a reason for that, because it gets dark there for 6 months and it's minus 80 degrees.
Right.
The same thing's happening in the Arctic. Neither of those places, Antarctica or the Arctic, are ever going to be ice-free or heat up or be warm. The idea is just stupid, and people are brainwashed to believe that.
Yeah.
It's crazy. So, and there's another. Okay, go ahead.
No, please go ahead. I was going to interject with something that's not quite relevant at the moment.
The final problem is they didn't talk at all about volcanism in Antarctica.
Mm-hmm.
And these volcanoes are under the ice sheets that we just showed you. It is estimated that in this paper alone that there are over 100 volcanoes under the ice sheet. And there are, in this article, in West Antarctica, almost 100 volcanoes under the ice there. Let's blow this up. Can you see this article? No, there it is.
Yes, I can. Yeah.
And look at how many there are under this ice sheet. Just over here in Western Antarctica.
Yeah.
So any number of they could be erupting. They could be causing upwelling of that salty water. Anything could be happening. the vagueness of the paper and the way it's worded as fear porn, using all the climate tard catchphrases, you know, that there's going to be more storms. If because of this, it's going to be more storms and it's more frequency, blah, blah, blah. Based on none of that is factual.
No. I mean, they even say in here, decades of surface freshening, strengthened stratification, trapping subsurface heat at depth, sustaining expanded sea ice coverage. What decades of surface freshening? We don't have that data. What are they talking about? It's like 2 decades at most, which is nothing. It's funny because it mirrors it mirrors the typical set of data that you get for anthropogenic global warming, right? We only ever get the data since the beginning of the Industrial Revolution. Never is included the data prior to the Industrial Revolution. You know, only this is so much worse. I mean, we're looking at, like, at least in their graphs, their own graphs, we're looking at 15 years of data. It's completely absurd. And especially in light of the minuscule amount of sea ice that is lost and gained over time, which we can see in some of the data that we have. It's such a minuscule amount compared to the size of sea ice in the Antarctic as a whole. It's completely insane to draw any conclusion from this.
Yeah.
I mean, I hardly even know where to start with all of the problems with this. I mean, we've already discussed a lot of it, but that was another thing they say in here at one point. I'm trying to find the context here. Modeling studies predict freshening in the Southern Ocean due to intense equatorward, that's a weird word, transport of fresh polar waters, enhanced precipitation, and increased Antarctic ice sheet melting. However, the rapid changes observed over the past decade, contradict the prevailing expectation of anthropogenic-driven freshening based on climate models, and 2 are unprecedented in the satellite record. This is a brand new technology, which they acknowledge readily. How is it an unprecedented satellite record? There is no prior satellite record of this.
Right, and you're looking at the data here. There's nothing unprecedented about that graph.
No, not at all. How could there be? There's not enough data.
The only thing you conclude is there's fluctuations in sea ice and salinity, and we've got 12 years of data on it. Where there's more sea ice, the salinity tends to go down. Where there's less sea ice, it tends to go up.
Right.
That's it. Nothing else can be concluded by this data.
Right. And it's funny too, because I constantly see this phrasing of like, well, apparently the mechanisms behind sea ice gain and sea ice retreat is more complicated than we realize. Well, if it's more complicated than you realize, then why do you think that you can draw a conclusion from such a limited set of data? You clearly don't understand how this works.
Without mentioning 100 volcanoes under the ice.
Right. Something else I noticed in this figure B, if you just scroll down a bit so we can see all 3 rows of the Antarctic sea ice.
Yes, ma'am.
There? Yeah, that's perfect. So, they're using this to indicate to show the SSS anomaly, right? And like, if you just look at the blue and red, so the blue being, let's just call it a negative anomaly, and the red being a positive anomaly, we start off blue from 2011 to 2015, and then it kind of abruptly changes to red. So we're now in the positive territory instead of the negative. But if you then start looking at around like 2021 to 2022, you see that these colors start balancing out a little bit.
Yeah, they're turning blue again. There's clearly a cycle.
There's a seesaw effect here. But yet they're claiming essentially that this red anomaly is an indication that we're at some kind of catastrophic tipping point.
That we're in a runaway event, then it's all over, folks.
I mean, you literally
That's literally what the article says.
Yes. You need like at least 20,000 years of data, probably more, to draw any conclusion from this data about what's happening with the Antarctic sea ice as a whole, like the trend currently.
Right, and the amount of sea ice there is unfathomable, and it barely fluctuates year to year. There is almost no real fluctuation since we began recording it. It grows and it shrinks. The Earth is a living creature.
Yeah,
and the ice has been in Antarctica for 40 million years, so everything is fine, folks. Yes. Except for all the people that write these science articles. They are not fine.
No, this is funny too. I was thinking about, they made such a big deal about these Polynia, whatever the correct pronunciation is, showing
holes
up.
In the ice. They're just holes in the ice.
Holes in the ice, showing up in 2016 and 2017. They make a really big deal out of that. Oh my God, we haven't seen these since the 70s, however that's relevant. I don't know. I mean, that speaks against the point you're trying to make, really. But then you notice that they're not on this map again after 2017. So the presumption from looking at this is that they've closed.
Imagine that.
It's like you're claiming there's this like catastrophic trend, and yet it appears to actually be reversing itself. I'm just so horrified by the state of science. I mean, we talk about this all the time, but it just never ceases to be mind-blowing.
Yeah. I think we oh, good.
How do you live with yourself? Being a person that writes a paper like this. This is like the lamest paper I think I've ever seen. The sheer lack of explanation, the drawing massive conclusions from an extremely limited amount of data, assumptions that are claimed in here that are stated as facts, which are not facts. It's just like, how do you live with yourself?
Yep. Garbage. All right. Let's talk about some real facts. How about that?
Yes, please.
So this is the latest coming from Electroverse, a friend of the channel. I believe I am a Patreon of theirs. I've been donating for years since they began. And I thought it was interesting. We can go over all of the real data sets on here, like the amount of ice building in Greenland just a week ago during the peak of the melt season. Another anomaly in the global warming world. And the fact that the Arctic sea ice extent, here we are over at, can you see this?
Yeah.
Okay, good. There we are. Where am I? Yeah, so this is over at NASA, the state of the sea ice, and you can come and see the Arctic extent. It's right in the normal range, going all the way back to 1979.
Mm-hmm.
Like nothing here is catastrophic.
Right.
And the same thing, look at how much more ice there is up here in Alaska this year. It didn't look like that last year. Yeah. So up here in Alaska, there's tons of ice where there wasn't a lot of ice. And on this side, by Greenland, there's not a lot of ice. So you can see that the ice shifts around.
Mm-hmm.
But this ice is never going away because 6 months of the year, it's dark and minus 50 here. People don't get that.
Right.
So until that changes, there will always be ice on the North and the South Pole. Mm-hmm. Even at like the warmest times on Earth, like now.
Right.
We're all going to burn up though.
Yeah. Okay, I mean, it's funny too, because when you think about let's say the variable in sea ice extent, in terms of how much of it there is and exactly where it is, even like a 5-year-old can sort of understand that there's going to be some natural variability in there.
Look at this. This is can you see this? Uh-huh. This is Arctic ice extent. This is the last 11 years. And there's the red line. That's current position right now, 7.6 last week. Mm-hmm. They're all the same. Nothing has changed.
Yeah. In the Arctic, especially in the grand scheme of things.
In 11 years.
If you consider the scale of the amount of ice that we're talking about.
Yeah.
This is the most minimal change you could imagine.
And you can see it goes up, it goes down, it goes up, it goes down.
Right.
Because there's nothing linear. The only thing linear is the thinking of climate alarmists that think the temperature goes in one direction.
Yeah.
All right, now let's take a look at some more mind-blowing data. Do you see this graph up top here?
Mm-hmm.
This is the precipitation in the contiguous United States for 12-month periods going back to 1970. And look at that line. That black line is the average.
Mm-hmm.
There is no change in precipitation in the United States whatsoever.
There is no trend at all.
I mean, it can't get any flatter than that.
Well, no, there is a trend. It's completely flat.
Yeah. And sometimes it gets wet and sometimes it gets dry.
Right.
And it looks like, if this is 50 years, there is definitely a sunspot cycle trend here, a 10-year packaging, of wetter and drier, which is probably driven by cosmic rays and cloud nucleation.
It's funny looking at this graph, because if this graph was some indication of anthropogenic global warming, somebody would mess with the math such that that trend line increased, because you can see how all of the lows are getting less low over time. And somewhat in the second half, the highs are getting slightly higher than previous ones.
I can see
right?
that a little
So
bit.
if you do the right math, you can make a trend line here that says that there's an increasing trend.
Increasing precipitation. But I thought global warming makes it droughts.
Well, my point is merely that, you can manipulate this data in whatever direction you want. Because again, I will say, this is still a very limited amount of data. This is 55 years of data, which isn't that big. Now, it tells us a little something. We can see clearly that things go up and down, up and down. We can see that in the Antarctic ice extent record as well. It's like, I'm so just blown away by the BS.
Okay, record cold across Central Europe. And this is right now, which is summer.
Mm-hmm.
And a few weeks ago, they were fear-mongering that it was going to get 84 degrees and there was a heat warning.
Which is not abnormal, actually.
And 84 degrees is not hot.
No.
But here we
They
are.
just changed the colors in the weather map. They make it bright red and they're like, alarm, alarm. Even though if you looked at the same map 10 years ago, it wouldn't look like that.
Yeah, but now the opposite is happening. A fierce summer chill has gripped Central Europe, dragging daytime highs down to autumn-like levels. And a handful of new record low daytime highs were set over the past few days, including look at this, Hoppenbingenberg, Germany, that logged 52.5 Fahrenheit as the high in summer. Yeah.
Wow.
In Czechia, 54.4 Fahrenheit was the high. Austria also. Slovakia saw 54.5. That is chilly for a high. Belgium, 57. Hungary, 60 as the high. Denmark, 61 for the high. France, 62 for the high. And the Netherlands, 63 for the high. Holy macaroni.
Can you imagine if we had here in Colorado, if we had a high of like the 50s or even 60s in the middle of the summer? Like, that's never happened.
That's our low, right?
And we're talking about living in a place where there's regularly in the summer, usually like 30-degree temperature swings, and in the winter, sometimes up to 60 degrees.
Yeah, and some more breaking of the narrative. Oh, we've got this still stalled here. Let's see if I can go to the no, that's not going to do it.
What's the is it possible to blow up the graph on the bottom right there?
The surface mass budget?
Yeah.
I'm going there.
Okay.
It's not updating on Electroverse's site, so I've got to get the raw data here.
Yeah.
Are you looking at what I'm looking at? Yeah, okay.
Oh, I see. Okay. Yeah. It's just this year I was not.
So this
looking
is
at
for
the,
July 11th yesterday, and I pointed out last week. Do you see how this blue line goes above the mass gain, mass loss line?
Yes.
In the melt season extends June, July, and August, and then it builds ice again on Greenland's ice sheet.
Mm-hmm.
It was so cold that they gained a gigaton of ice at the peak of the melt season.
Right.
Now, they've been fear-mongering about Greenland for years, saying it's, collapsing and this and that and the other. But this is the data, and it couldn't be further from the truth.
Right.
Yeah.
I mean, if you look at the sort of the stretch of the data, over the course of 1981, 2010, that gray shaded area.
Yeah.
I mean, we're all the way at the top of that gray shaded area, if not higher than that.
Yeah, especially last week when we gained ice in the peak melt season.
Right. It's for the period 1981 to 2010, it's record setting, which is a small period of time. But, obviously fear mongering about this doesn't make
And
any
a lot
sense.
of the peaks during the mass gain period back in March, February, and January were record peaks, extending that gray line even higher.
Yeah.
Where we gained as much as 10 or 9, 10 or more gigatons of ice in a single day.
Mm-hmm.
Those must have been chilly days.
Mm-hmm.
All right. I wanted to finish up with this cool find. And this is from an old website called Real Climate Tools that I believe Tony Heller has something to do with. Because I was watching an interview with him, and that's where they talked about Real Climate Tools, and I found this. This is the Earth and all of the tropical storms we know from 1851 to present.
Wow.
Look at the amount in the Atlantic basin.
Yeah.
All right. So this is the U.S. at the top, if you can't see it from all those tracks.
Mm-hmm.
And you can see the Pacific storms all kind of start right down here off of Baja. And then you come out towards Hawaii where there's almost nothing. Isn't that weird?
I was more struck by how there's like nothing going on around South America.
Yeah. Zero.
There's like one storm. Look at that. That's interesting.
This is the dead zone here.
Yeah.
And so there's tons of them that go from Australia to Africa. And the equator, look at the equator. You can't get a rotating storm at the equator because I guess the magnetohydrodynamics don't work there. Everything's neutral.
Yeah.
Yeah. Just a fascinating. Why this dead zone?
Yeah. It's very interesting.
If you guys have any ideas what's going on here, leave a comment below.
Cool. The whole southern Atlantic is like, there's nothing doing. And then, of course, the southern, what would you call that? Eastern Pacific? Or would you call that the Western Pacific? I don't know.
This?
Yeah.
Southeast Pacific. They call this the Eastern Pacific where all these storms start.
Okay. Yeah.
But yeah, that is fascinating.
That's very cool.
All right, we'll leave you links to this below. Anything else you want to talk about?
Well, just going back to our first topic with this fear mongering. I mean, we talked on a show fairly recently. We evaluated a paper that came out about the AMOC that basically showed that there was, as far as we know, there's nothing stopping with the AMOC right now, is the conclusion we came to. And that's what the conclusion that the paper came to. But it's funny because like one of these media articles says, while scientists are 98% certain that the AMOC will stop flowing by 2100, Recent studies suggest that the collapse could come as soon as this year, or at least in the next few decades. Who's saying that?
Absolutely no one.
Now, I'm not
And
throwing out
where does the 98% come from?
I have no idea. They're 98% certain that it'll stop by 2100, but it might happen next year. Huh? Now, I'm not saying that it's not possible for the AMOC to shut down, because sorry about that. I'm certainly wondering about that. And I'm, of course, wondering about how the change in the SMOC, what does it stand for again?
The Southern Meridional Overturning Circulation.
The SMOC versus the AMOC. I can certainly imagine that changes in the SMOC may affect the AMOC, and maybe we're just not seeing the effects of that yet. But like, I mean, they say all of these things that are not based on any facts. Like, they also say that the ocean's role as a carbon sink currently absorbs about 25% of all anthropogenic CO2 emissions. Not that that matters, but like, really? Does it? Because the next sentence, they're talking about this increased salinity in the Antarctic will result in releasing heat from the deep ocean and CO2. So in the next sentence, they say this could double current atmospheric CO2 concentrations.
That's made up.
It absorbs 25% of our CO2 emissions, but it might double. What? Like, based on what data?
Right. And humans are only responsible for 4% of total CO2 annually.
Right. The 0.04% of the atmosphere that's CO2. I just, it's again, just this, like, when did science stop being based on the data? Because at this point, we are looking at crap papers that just pretend to be relying on data, but drawing these grandiose conclusions based on almost nothing. Like I said, it's like saying two dots and one being lower than the other indicate a downward trend. It's the equivalent of saying that. It's just, it's mind-blowing and it's infuriating, and I'm just like totally sick of it. Like, science needs a complete reset at this point.
Agreed.
It's always highly influenced by somebody that has an agenda, whoever that is. Somebody having an agenda to say that human beings are responsible for everything horrible that happens on Earth, so that we as human beings can be restricted and controlled. Or it's big pharma influencing medical papers and the conclusions and telling us that things that are good for us are bad for us, and things that are bad for us are good for us. It's just like, what happened to the data? What happened to anybody's interest in truth? That there are that many human beings that are that susceptible to whatever influence that leads them to write garbage papers like this,
right,
I find extremely disheartening.
Well, and then they get shared by the largest scientific agencies on Earth, like the European Space Agency right here.
Right. Right. Like, why did you go into science? If you weren't actually interested in the truth, then why in the world did you go into science? It's like, we have all of these doctors who aren't interested in learning anything new.
Right.
And if you're somebody like me, who is a pain in the ass patient, who does a lot of research and asks a lot of questions, I'm like a thorn in your side. But it's like, if you weren't interested in actual science, then why did you become a doctor? Why aren't you continuing to read new research? And why are you completely uninterested in anything that contradicts whatever narrative you're putting out there? I don't get it. And it makes me really sad for humanity. Like, we talk about in the Yuga cycle, getting to the sort of the bottom of the Yuga cycle, where virtue is at its worst and our understanding of science is at its worst. And supposedly we're past that bottom point in the Yuga cycle. And yet stuff like this makes me think, No, we're only reaching the bottom now, you know?
Or maybe there's small blips and, you know, we're in one of those blips.
Well, yeah, I think the reality is that the bottom of the Yuga cycle spans an extraordinarily long period of time, and you know, because we're talking about a Yuga cycle that lasts 26,000 years.
Yes.
So you know, there's like any other trend in the universe. It's never a continuous line, right? There's ups and downs and ups and downs, and there might be an overall trend, but that's pretty hard to see from this perspective in regard to where we're at in that cycle.
Yeah, indeed.
But we're generally speaking, we're still in the bottom. And this to me proves it.
All right, great show. Ladies and gentlemen, we appreciate you all watching us. You could really help the channel grow by sharing this video. Also, if you're not following, follow us now. And if you haven't chatted, leave a unique chat below. All you have to do is say hi. It'll help out the channel. We appreciate y'all for coming. And we'll see you all next week. Leave a comment below to suggest a potential name for our show exclusively here on Rumble.
Yes.
And we'll see you soon.